Welcome to the ultimate one-shot revision of chapter Physical and Chemical Changes, a fun and fascinating part of your Class 7 NCERT science journey. From burning magnesium to making crystals, we are going to experience the world of transformations. Hello dear students, I am Dr. Aamarpali Roy and I am thrilled to welcome you to this exciting learning session brought to you by Saujanaya International Educational Foundation. This journey of education and exploration has been deeply inspired by my beloved mother and teacher Srimati Sneh Lata ji, whose vision and commitment to nurturing young minds continue to drive our mission, making learning fun, accessible and meaningful for every student. So grab your notebooks, stay curious and get ready to explore the wonderful world of transformations, physical and chemical changes. Every day we experience changes in our surroundings. For example, milk turning into curd or ice melting in a cold drink, rusting of iron. In this chapter, we explored two types of changes, physical and chemical. First, physical changes. Definition: a physical change is one in which a substance changes its physical properties like shape, size, color or state. No new substance is made. Think of ice melting, stretching of a rubber band or dissolving sugar in water. Let's explore a simple activity that helps us understand physical changes. Step 1. Take a piece of paper and cut it into 4 square pieces. Step 2. Now take each of those squares and cut them into even smaller square pieces. You will notice that the shape and size of the paper have changed. But here is the important part. No new substance has been formed. This is a physical change. This paper is still paper. Let's move to second activity, reshaping chalk. This simple activity demonstrates another example of a physical change. Step 1. Start by crushing a piece of chalk into a fine dust. Add a little water to the chalk dust to form a paste. Now roll the paste into the shape of chalk stick and leave it to dry. You will see that the shape has been restored. There is no new substance formed in the process. Again, this is a physical change, a reversible change in form. The chalk is still made of same material. It is a reversible process and there is no chemical reaction involved in it. Let's perform activity 3. Reversible change of state. Step 1. Take some ice cubes in a glass or a plastic tumbler. Place the tumbler in a sunlight and wait for some of the ice to melt. You will notice a mixture of ice and water in the tumbler. Place the tumbler into a freezing mix like ice with salt. You will see the water freezes back into ice. That means the state changed twice, from ice to water and back to ice. No new substance is formed during this process. This is a physical change. It is reversible change in state of matter from solid to liquid and back to solid. It is a reversible process, but there is no chemical reaction involved. Let us understand condensation through a simple activity. Step 1. Boil water in a container. As the water heats up, you will observe steam rising. Hold the lid over the steam for a few seconds. You will notice water droplets forming on the inner surface of the lid. This happens because steam cools down and changes from gas to liquid. This is called condensation. Steam changes back into water. This is a physical change, not a chemical one. It is a change in the state of matter, not in the substance itself. It is a reversible process. Here is an activity to observe color change on heating. Caution: be very careful. Use tongs and maintain a safe distance from the flame. Hold a blade or metal strip using tongs over a flame. Watch closely. The tip starts to change color. Let it cool for a while and observe again. You will notice that the tip changes color when heated, and after cooling it returns to its original color. Conclusion: this is a physical change. The change is temporary and caused by heat energy. No new substance is formed. Only a change in appearance is there. Now let's talk about chemical changes. The real transformer in science. A chemical change is when one or more new substances are formed. Let us break it down. First, these changes are irreversible. That means once they happen, you cannot easily undo them. Next, they always lead to new substances being formed. And often you will notice things like heat, smoke, bubbles, color change, or even a new smell. Some everyday examples: rusting of iron, burning of paper, digestion of food, or milk turning into curd. All are chemical changes. Remember this: if something new is created and it cannot be changed back easily, you have just witnessed a chemical change. Next is the most exciting experiments: burning of magnesium. But remember, always do this under the observation of elderly. First, take a strip of magnesium ribbon and gently clean it with a sandpaper, just to remove the oxide layer for a clean burning. Now, bring the tip close to candle flame. It bursts into brilliant white light. Soon, you will notice a fine white powdery ash forming. This is magnesium oxide. If you mix this ash with water, it forms magnesium hydroxide, a mild base, another new substance. It concludes that this is a chemical change. It is reversible, forms new substances, and produces light energy. Let us explore a simple but fascinating chemical reaction: the reaction of copper sulphate with iron in a solution. Step 1. Dissolve copper sulphate in water. Then add few drops of dilute sulfuric acid. Now drop in an iron nail or a shaving blade. Wait for about 30 minutes. After 30 minutes, you will notice that the blue color of the solution slowly turns green and a brown deposit appears on the iron surface. This concludes that this is a chemical change. The reaction is copper sulphate plus iron gives iron sulphate plus copper. Two new substances are formed. This is perfect example of color change, new substances, and an irreversible reaction. When iron is added to copper sulphate solution, a chemical reaction takes place. The blue copper sulphate reacts with iron to form green iron sulphate, and a brown deposit of copper is seen on the iron. Let's perform activity 8. The reaction between vinegar and baking soda, which produces carbon dioxide. Take a test tube and add some vinegar, that is acetic acid. Then add a pinch of baking soda, also known as sodium bicarbonate. You will see bubbles form immediately, that is a gas being released. Now pass this gas through lime water. The lime water turns milky, which confirms the presence of carbon dioxide gas. It concludes that this is a chemical change. Carbon dioxide is a new substance formed and it reacts with lime water to form calcium carbonate, turning it milky. This activity shows gas formation, bubbling, and it is an irreversible change. This simple activity shows a clear chemical change with the gas formation and an irreversible reaction. Let us talk about one of the Earth's most important shields, the ozone layer. So, what is ozone layer? It is a layer high up in Earth's atmosphere made of ozone gas, that is O3. Its main function is to protect us from sun's harmful ultraviolet or UV radiations. How does it work? Ozone molecules absorb UV rays. In doing so, they break down into oxygen gas. This is a chemical change because a new substance is formed. Why does this matter? Without the ozone layer, dangerous UV rays would hit Earth directly. That could lead to skin cancer, crop damage, and harm to animals. Ozone truly is our natural shield. When ozone breaks into oxygen, it's not just a physical process, it is a chemical change that helps protect life on Earth. Let us understand rusting of iron, a slow but serious destroyer. What is rusting? Rusting is a chemical change where iron reacts with oxygen and water to form a reddish-brown, flaky substance called rust. Why is rusting important to study? Because over time, it destroys iron objects like bridges, ships, vehicles and tools, causing huge monetary losses. Here is the chemical equation. Iron plus oxygen plus water forming rust, which is iron oxide, Fe2O3. What are the key conditions for rusting? Rusting happens when both oxygen and moisture are present. The more humidity in the air, the faster rusting occurs. Rusting can be prevented. We can use paint, grease or galvanization, coating the iron with zinc to stop rust from forming. Rusting may be slow, but it is powerful. Let us protect our iron. Prevention of rusting. Why do we need to prevent rusting? Rusting weakens iron and steel objects, making them brittle and unsafe. This leads to huge financial losses, especially in industries like construction, transportation, and shipping. So, how can we prevent rusting? First, painting or greasing the iron surface. This method blocks contact between iron and air or moisture, stopping rust from forming. However, the coating needs to be reapplied regularly to stay effective. Another common method is galvanization. This involves coating iron with a layer of zinc. Zinc acts as a protective shield, preventing oxygen and water from reaching the iron. By using these methods, we can protect iron objects, extending their life and save costs. Another way to prevent rust is using stainless steel, an alloy of iron with chromium, nickel and manganese. It does not rust. Why do ships rust faster? Because of constant contact with salty seawater. Salt speeds up rusting and even painted ships lose some iron each year, causing huge maintenance costs worldwide. Always keep iron dry and protected to prevent rust. Crystallization is a method to get pure crystals from a solution. Prepare a saturated solution of copper sulphate in hot water, filter it and let it cool without disturbance. Crystals form as the solution cools. This is a physical change, no new substance is formed. In this activity, we will make crystals of copper sulphate a physical change. Use only dilute acid and handle hot solutions carefully. Steps. Take hot water and add a few drops of dilute sulfuric acid. Slowly add copper sulphate until no more dissolves. Filter the solution and let it cool undisturbed. Wait and observe. Blue copper sulphate crystals form as the solution cools. This is a physical change. No new substance is formed. Recap. Physical changes. No new substance, often reversible. Chemical changes. New substances are formed. They are reversible. Melting, wax. Physical, burning candle, chemical. Lighting a candle, both. Spellings. Here are some important spellings to remember. Write them down minimum 5 times and spell them loudly while writing. Spelling worksheets, physical and chemical changes, jumbled word, unscramble the letters to find the correct science term. The iron pillar is located near the Qutub Minar in Delhi, India. It dates back to the rule of Chandragupta II, a Gupta emperor. This pillar stands in the Qutub complex, a UNESCO World Heritage Site. Iron pillar has resisted rusting for over 1600 years. Pause and check your understanding. Let us test your memory. Pause the video now and try these questions. Once you have answered, compare your responses with mine. Ready? Let us see how well you did. Practice writing these answers in your notebook. It will help you remember better. You can also comment below if you want answers to NCERT questions. Great job today. Remember to read your NCERT book, ask questions and practice regularly. If you want solutions or worksheets, just drop a comment below. Until next time, keep moving forward and keep learning. Feel free to share your doubts or questions in the comments and don't forget to subscribe for the next chapter. Thank you.